Hi all, I want to go ahead and get started on the worksheet we had in class on Friday. Now, please know that this worksheet is from All Things Algebra, and I'm going to be working on the odd examples. Okay, so when I'm working on these ones here, off to the left side, you'll see that I've included my notes or notes that go along with the worksheet. So be sure to fill in those notes and write them as we go along. Okay. And a couple of these examples, I'm going to go into some more detail so that I'm really talking through some of these steps. And then other times I will just go through them and just work out what is expected of you. But I do want to make sure that everybody understands the actual process that is going on. Okay, well, let's get started with number 1. So what we are doing is we are solving one-step equations here. And our goal is to isolate the variable. Variable does not always have to be x. It can be m, it can be n, pretty much any letter in the alphabet. It can also be a Greek symbol. So just know that we are trying to get that variable by itself. Okay, so on example number 1, we are going to be starting with drawing a line through the equal sign. Now, I don't always do that, but at this point, what I want you guys to see is there's two sides to this equation. Okay, the left side and the right side, and that's typically how I refer to it. Now, I always go look first if there's anything that I can combine on the left side. So when I look at m plus 12, I cannot combine those two terms because one has a variable and the other does not. And again, it'd have to be the same variable. So it would have to be like m plus 12m. On the right side, there's only one term. It's just a constant value of 10. So there's nothing to combine there either. So what we're going to do is instead of adding 12, we are actually going to subtract 12 from each side. And because it's an equation, we have to keep it equal. We do have to do the same thing to both sides to keep it fair. All right, now on this one here, I will get m positive 12 and negative 12. They do cancel out, okay? They are eliminated, all right? They do actually make 0. Here, then I've got 10 minus 12. Well, that gives me negative 2. So my solution here on this one is m will have to equal negative 2. Well, I want to make sure that I did my work correctly. So to check to see that I did my work correctly, I'm going to go ahead and check this problem. Okay, so I'm going to go ahead and rewrite the original problem. Let me erase this x that I put here. Okay, I'm going to rewrite the original problem, but instead of m, I'm going to put an open set of parentheses there because now I know what m should equal. Okay. M should equal negative 2. So that's what I want to check. I want to make sure that it does equal negative 2. So I'm going to substitute in negative 2 here. Now I'm going to combine the left side of the equation. So that gives me positive 10, and I want to confirm that it does equal the right side of the equation, which was also 10. If those two are equal, that's a good check. That means that I did my work correctly, and that means that my solution is negative 2. Okay. Okay, so let's go on to number 3. Now on number 3, we're still looking at isolating the variable. This time our variable is y, so we want to get y by itself. Okay, but when we multiply or divide, we have to do it to each term. And I say that because sometimes people will say do it to each side. And that's with addition and subtraction. With multiplying and dividing, it's got to be to each term. Okay, so then on this one, we have one term on the left side, one term on the right side. So we're going to divide each term. Okay, and now what's being multiplied to the y is negative 7. So what we're going to do is we're going to divide both sides, or each term, I should say. I just said I wasn't going to say side. We're going to divide each term by -7. Now, I understand when people say, or I understand what people mean when they say -7 divided by -7 cancels out. But it actually doesn't, because it doesn't cancel out to be 0. It reduces to be 1. Okay. So if you're going to say cancel out, just make sure you understand that actually means it's reducing to 1. So that is y is equal to, a negative divided by a negative is going to be a positive, and 91 divided by 7 is going to be 13. Okay. Now on this one as well, I'm going to go ahead and check my work to make sure that my solution is correct and I didn't make some mistake in my computation, because some of us might not know 91 divided by 7. We want to make sure that if we were trying to guess close, that we can fix that. All right, so on this one, let me erase this marking that I did here so I can see the original equation. That original equation is -7. Instead of a y, I'm going to put in an open set of parentheses, is equal to -91. Now, using substitution, I'm going to take 13 and substitute 13 in for where y originally was. Now, -7 times 13. Think about this way. If I do -7 times 10 and -7 times 3, that's okay, because all I've done is taken this 13 and breaking it up into 2 parts. Okay, both little pieces are going to be multiplied by -7 and then combined. So -7 times 10 is -70. -7 times 3 is -21. And those two combined gives me -91. Could I have just gotten a calculator and did that? Absolutely. But what I want you guys to see here is, if you don't have a calculator, that's just the way that you could use mental math to multiply that left side. You could also still go through and do 13 times 7. Okay, and then just remember that a positive times a negative is going to give you a negative solution. Okay, so that is something that you could still do. This was just a different way of me doing some mental math. Now, I have -91 on the left side. Does it equal -91 on the right side? Yes. So my solution is y equals 13, and that did work when I checked it. Okay. All right, now we're going to practice with fractions. So we're going to be practicing getting rid of a fraction. Okay, so we are going to be multiplying by the reciprocal. The reciprocal means just instead of being 2/3, now it's going to be 3/2. Okay. So let me pick that purple back up. All right, I want to get x by itself, but I still want to go through first and look at if there's anything that I can combine on the left side and if there's anything I can combine on the right side, which there is not. Okay, so to multiply, instead of dividing, we are going to multiply by its reciprocal. Whatever I do to the left side, I also have to do to the right side. Now, on the left side of the equation, 3 times 2 is 6, 2 times 3 is 6, 6 divided by 6 makes 1. So ultimately what we see here, though, is if I have a 3 in the numerator and a 3 in the denominator, they're going to reduce to 1. If I have a 2 in the numerator and a 2 in the denominator, they're also going to reduce to 1. So those two there are just going to, that whole fraction is going to reduce to 1. So I'm going to be left with x is equal to, now on the right side, keep in mind that this 10 is, right now it's just a whole number, but we can make it a fraction by just writing it over 1. Okay, numerator times numerator, 10 times 3 is 30. 1 times 2 is 2. and we get x equals 15. Okay. Because this is the first time that we did it with a fraction, I am going to go ahead and check my work just to make sure that we didn't make a mistake here. Okay. So let me erase these markings that I made. That 3 could stay there. I wasn't worried about that. All right, so I'm going to go ahead and do 2/3 times 15. And I'm going to go ahead and put that 15 over 1 now so it can be a fraction. Is equal to 10. Now let's see if that works out nicely the way we'd like. All right, on the left side, 2 times 15 is 30. 30 times, or divided by 3. 30 divided by 3 is 10. And yes, 10 equals 10. That does check out. So my answer is correct when I have x equals 15. Okay. All right. So on this one here, we're still going to multiply by the reciprocal, but we're going to keep the sign with it. Now, when I'm looking at problem number 5 here, it was, let me pick up a different color. It was a positive 2 over 3. It's still a positive, but now it's 3 over 2. So I never changed the sign. I just reciprocated the fraction. So when we're looking at number 7, I'm going to take the sign with it. So rather than multiplying by negative 6 over 5, I don't want to like try to squeeze this in there because I know sometimes with your paper it might not work. I'm going to multiply. Yeah, I'm going to rewrite this. Just rewrite the whole problem so I have more room to write. Negative 6 over 5k is equal to 12. Okay. So what I'm going to do is I'm going to multiply by the reciprocal of negative 6 over 5. Again, but whatever I do to the left side, I also have to do to the right side. Okay. So that reciprocal value is going to be negative 5 over 6. Okay. So negative 5 over 6. All right, on the left side, the negative 5, or I should say the 5 and the 5 cancel out, as you all like to think of it, or really 6 and 6 reduce to 1. That negative and that negative, they're going to make it a positive. So on the left side, we are going to have k equals. Now on the right side, this really is 12 over 1. Okay, so 12 times, or positive times a negative is going to be a negative. 12 times 5 is going to be 60. 1 times 6 is going to be 6. And that gives us k equals negative 10. All right, so that's going to be our solution. All right. Now what I'm going to do is I am going to go on to two-step equations. So now we're going to take what we did on 1 and 3 and what we did on 5 and 7, and we're going to put both pieces together. Okay. So with a two-step equation, step 1 is we are going to either undo addition and subtraction first to remove any constant term. And then we are going to undo multiplication and division to remove any coefficient. Okay, here on the left side, I put some notes if you're unsure of what a constant is or what a coefficient is. So if you need that, please go ahead and pause the video and write that information down. Okay. All right, I'm going to go ahead and start on number 9. All right, so step 1 said undo addition and subtraction first. So I'm going to subtract 8 from both sides. Okay. Now, one thing on the left side that I want to make sure is I want to make sure that this 50 didn't have an x with it. Because if that 50 did have an x, I wouldn't be able to combine these two because they wouldn't be like terms. Okay, but since 50 does not have an x, they're both constant terms, I can combine them. All right, so on the left side, we have 6x. 8 and negative 8, they do cancel out, make 0, which is equal to 42. Okay. Now to undo multiplication and division, we're going to do that to each term. Okay, so instead of multiplying by 6, every term is going to be divided by 6. 6 divided by 6 reduces to 1. So I've got x equals 42 divided by 6 is 7. So we get x equals 7. Okay. All right, now let's go down to number 11. On number 11, this time, notice that the variable is on the right side of the equation. So we're going to leave the variable on the right side. We could move the variable over to the left side. It really doesn't matter which order you take it in. It's just going to be whatever you feel, however you feel better about writing it. Okay, so I'm going to go ahead and leave it on the left side for this one, though. I don't want to move it over. And let's go ahead and do that. So first thing is I'm going to subtract 9 from both sides. And since 13 is a constant, I will be able to subtract 9 from it because they are like terms. So 13 minus 9 gives me 4. Now I'm going to multiply or divide off whatever I need to do. Well, since it's negative 4 times k, the inverse is dividing by 4. Dividing each term by negative 4. If I didn't say that right, negative 4. Okay. 4 divided by negative 4 is negative 1. On the right side, negative 4 divided by negative 4 reduces to 1. So then I've got k. So my solution is k equals negative 1. All right, so let's go on to the second worksheet. Okay. These two here on number 13 and 15 involve fractions. Still the same process, but like we were talking about earlier, we have to remember that with these ones, what we're going to try to do first is we're going to try to, well, we're going to, but our thought process is what do we need to do first so that we can solve for x? So should our first step be to move the 7 to the other side or multiply both sides by 2? Well, in this case, I want to get that fraction by itself because the variable is part of the fraction. So I want to go ahead and move that 7. Okay. So I'm going to add 7 to the left side, add 7 to the right side. On the left side, I still have x over 2. 7, negative 7 and positive 7 cancel out, is equal to 16. Okay. Now, instead of dividing by 2, what we're going to do is we are going to multiply by 2. Again, whatever I do to one side, we have to do to the other side. Okay. These two here, this is like 2 over 1. Okay. So these 2's will reduce to 1. X divided by 1 just leaves me x. And x equals 32. Okay. All right. Now let's go look at problem number 15. Now, on problem number 15, I'm going to do that same process. Since I can get rid of that 22 on the left side, I'm going to go ahead and do that. So instead of positive 22, I'm going to subtract 22. Okay. I didn't draw that bar down the equal sign. If you'd like to, go ahead and do that. So then I have 3/5 x. These two here cancel out, equals 6. Okay. All right, now what I'm going to do is multiply by the reciprocal of 3/5. So that's going to be 5/3. And since it's positive, I'm going to keep it positive. Remember, 6 really is a fraction. It's just over 1. So then 5 in the numerator, 5 in the denominator reduce to 1. 3 divided by 3 reduces to 1. So I'm left with x, not pink. X is equal to 6 times 5 is 30. 1 times 3 is 3. And we get x equals 10. Okay. All right, I'm going to go back and I'm going to erase this. You're welcome to leave it as you have it. But for some of you, I think some of you guys see something which is reducing before I multiply everything and do this step. So I'm going to go back and do this problem again. So let me try to just erase what I think I need to erase here. Let me go ahead and erase it all. All right, so what I'm going to do on this one is I'm going to go ahead and start with that line just so I see it. Okay, I'm going to say I'm going to take the positive 22, and I know it's not going to be a positive 22 on the right side because it's going to eliminate. Instead, it's going to be a negative 22. Sorry, it's not going to be a positive 22 on the left side. It's going to be a negative 22 on the left side, right side. And if I could speak this morning, that would help. All right, so now on the left side of the equation, I have 3 over 5x is equal to 6. Now we're still multiplying by the reciprocal. Okay. Some of you can see, of course, on the left side that these would just reduce to 1, right? 5/3 times 3/5 is 15 over 15. That just makes 1. So then we've got x is equal to, well, if you know that 6 is in the numerator and that 3 is in the denominator, can we cross cancel? How many times does 3 go into 6? Well, 2. How many times does 3 go into 3? 1. So now the denominator is just 1, so that's not of importance to us at this time. So all we have left is 2 times 5, and we've got 10. The same exact answer, it's just a different way to show your work. Okay? All right. So now what we're going to do is we're going to go down to number 17. Actually, I'm going to skip number 17 because it's very similar, and I'm going to leave that one there for you guys to practice on. So I do want you guys to do this one. Okay, this one here is one that is still being looked at. All right, now on this next one, number 19 and 20. The examples below are different in that multiplication and division has to be done first, followed by division and subtraction. The reason they're different is because this one, the x plus 11 is all in the numerator. Okay, so all of that is being divided by 8. So we have to get rid of that dividing by 8 before we can worry about getting rid of that 11. Now I want you to go back really quickly and look at number 13 on your worksheet. Okay, so on number 13, we had x halves minus 7. Let me get back to number 13. Okay, let me erase this stuff on number 13. So on this case, the negative 7 was not part of the numerator. That was not part of the fraction at all. So we could move that -7 to the other side. On this time, the +11 is part of the numerator, so we can't just move it. Okay, we have to get rid of the denominator first. So let me rewrite this so we have more room here. X plus 11 over 8 is equal to -3. So what I'm going to do first is get rid of that denominator. So I'm going to multiply both sides by 8. This 8 in the numerator and this 8 in the denominator reduce to 1. So then I'm left with x plus 11 is equal to -24. Okay. And now I can go ahead and subtract that 11 from both sides. And I get x is equal to -35. All right, and I'm going to go ahead and leave number 21 for you guys to try. All right, and if you have any questions, reach out to me on Remind, and I am happy to help you with this stuff. All right, you all have a great afternoon and a great weekend.